Yeah.
that's fine. Okay, so what is data actually? So data is like facts and statistics collected together for some reference. Okay, a simple sentence like data are facts and statistics collected together for some reference. So it could be some quantities, characters, symbols, right? Performed by a computer or some machine. Like if we talk about like sensor data, okay, those are generated by some of the devices, right? And sometimes we get data from like computer, like in the form of binary, right? Some symbols, some textual data also we may get, like say there are newspapers, blogs, etc. So those are textual data. Sometimes we get data in the form of sensors, like a lot of countries, all the countries conduct sensors, right? So that is also data, right? It could be any quantity, character, symbol, which is properly represented. Okay, sometimes it could be in the form of electrical signals. Okay, uh, just give me a minute. Somebody is trying to join actually. Okay, now so basically data are characteristics or information, sometimes numerical, sometimes categorical. Okay, which is properly presented in a tabular format so that it's easier to understand like what are the different facts or information that that particular data is going to tell us, right? So that's called data. Okay, so there are two types of data primarily. One is quantitative data and second is qualitative data. What is quantitative data? Quantitative data is which you can measure. Okay, which can be measured, that is known as quantitative data. um, like what are those? Like could be like height, weight, okay, rainfall in centimeter, quantity of milk, and so on, many more, right? Population. So these are all quantitative data because there is measurement. You know, like okay, so what is 10, what is 20, what is 50, etc., right? What is say 100.5, 100.2 degree centigrade, etc. So these are all data, quantitative. And what is qualitative data? Qualitative data are like it describes some qualities or characteristics. Okay, so and it is a non-numeric type. It could be categories or classes, right? Or some of the uh, characteristics or qualities, like say grade of a student, hair color, skin color, okay, ethnicity, uh, gender, right? So these are sorry. So these are qualitative data because you can't measure it, right? And you can measure in terms of putting some numeric values, but uh, these are these are some characteristics or qualities primarily, right? So these are qualitative data. Clear, all of you? Write yes in chat box if it's clear. Okay, good. Now, if I talk about the different types of variables, like variable can be two types: numerical. Okay, what is numerical? Okay, in numerical, I can have two types of variables: discrete and continuous. What is discrete? Discrete variable is that variable which has discrete data. Discrete means mutually exclusive, right? One like one is not equal to two, right? So this one, two, three, four, these are mutually exclusive from each other, right? And these are discrete. So discrete data and continuous data. What is continuous data? Continuous data can have unlimited number of values in between a range or say interval. Suppose, say for height, for the entire world, for height, say 5 feet to 6.5 feet. Okay, there could be unlimited or countably infinite number of observations in between 5 to 6.5 feet, right? So these are like some data of examples of continuous variable, which is not discrete variable but continuous. In a range or in an interval, it can contain countably infinite or infinite number of observations. So like we have um, discrete data or continuous data, and then these are numerical data. And what is categorical data? Categorical data could be nominal and ordinal. What is nominal data? Nominal data is like say gender, okay, ethnicity. These are nominal data. I mean, those are categorical, but you do not have a order. Okay, so like gender, you can't say like one is, I mean, male is better than female or female is better than male, right? You can't say that. You should not say that. And also for ethnicity. like Indian, African, Indo-American, and those things, American, right? So ethnicity also you cannot order it, right? You can't tell that Indians are better than those people, or American are better than those people, right? So all are human beings, all are same. And that's called nominal data. And what is ordinal data? Ordinal data is again a categorical data, but it can be ordered. Okay, like say grade of a student. When I'm talking about grade of a student, A plus plus is better than A. A is better than B plus. B plus. B plus is better than B, etc. Right? That is called ordinal data. Right? So you understood the difference between nominal and ordinal data, discrete and continuous data. Yes, if you write, I mean, if you understood, write in chat box. Okay, good. Right. So, okay. So now let's talk about types of variables. I have already told you, like discrete variable. Okay, continue. I mean, having discrete values. Okay, like say male. Um, okay, so discrete variable like say 1, 2, 3, 4, etc. Continuous like say height, weight, etc. Right? Or say distance, right? Interval. Okay, now after discrete and continuous variable, there are interval and ratio scale also. So what is interval scale? Interval is like which you can put in some interval, like say 5 degrees, let's say 5 degrees Celsius to 10 degrees Celsius, 10 degrees Celsius to 15 degrees Celsius, like this, right? It could be like temperature measured in Celsius or Fahrenheit. That are interval variables. Okay, and what is ratio variable? Ratio variable is same as interval variable, but only one difference is ratio variable has a pure zero. I mean, there's that zero meaning zero only. Okay. So remember, in centigrade, if I talk about temperature in Celsius, okay, so zero is not actual zero. Zero is having still some meaning, right? I mean, 0 degree centigrade has some cold, right? So that's not a pure zero. So that's why if I talk about temperature measured in Celsius degree, that is an interval variable and not ratio variable. Because to be a ratio variable, I need to have a dedicated zero and whose meaning is also zero. Okay, like say distance. Okay, zero distance means truly zero distance, right? That's why distance kind of variables are ratio variable. Okay, got it. Now I discussed about nominal like gender, ethnicity, which cannot be ordered or should not be ordered. And ordinal variable I have discussed, like say which can be ranked, right? The grade of a student. And so these are different types of variables. Okay, now once we understood the data and the variables, we have understood, right? Now I will define what is statistics. So basically statistics is the collection of data, and then tabulation of data, then visualization of data, then analysis of data, then interpretation of data, and finally reporting of data. Okay, so statistical science is a process of collecting, tabulating, visualizing, analyzing, interpreting, and reporting data. So I'll explain you one by one. Okay. Okay. So basically, if I want to define like statistics is concerned like for developing and studying methods for collecting, organizing, analyzing, interpreting, and presenting empirical data. Empirical data means data collecting, I mean collected at the time of research. Okay, at the time of survey, through some questionnaire, surveys, etc. Now, okay, now I'll talk about one by one, right? So collection, what is collection, what is tabulation, what is visualization, what is analysis, what is interpretation, and what is reporting. So let's move forward. So remember, what is collection actually? So before analyzing, before visualizing, you need to collect data, right? And then how do you collect data? There are numerous methods by which you can collect data. Okay. Initially, I mean, we can have primary data or secondary data. What is primary data? Primary data is that data which is collected for the first time. Okay. Suppose census for 2010, census for 2020. Uh, okay. So, sorry, census, I think 2001 it happened. So 2001 and 2011. Okay. So these are like collected for the first time. Right? So purely raw data and collected for the first time. So those are primary data. primary data is collected at the time of research, okay, and collected totally newly. I mean, it has no connection with old data, and that data itself becomes secondary when some scientist or researcher use the census data to do some analysis. That is called secondary data. So primary data always becomes secondary data when it is going to be used for second time, third time, etc. Right? So you understood the difference between primary data and secondary data, all of you? Yes or no? You can write in chat box. Okay, good. So that we call primary data or secondary data. Now, there could be different data collection methods. Okay, there could be interviews, there could be observations. Without interviews, there could be questionnaires and surveys. Uh, okay, someone is saying, can you? Okay, Arjun, can you once again explain primary data? Okay. So primary data is that data which you collect for the first time for a research purpose. Okay, so it's not old data; it's collected for the first time for research, and that data becomes secondary when someone else is going to use it for the at a later phase to do some research, to do some analysis, etc. Right? That becomes secondary. So how data are being collected: interviews, observations, questionnaires and surveys, documents and records, focus groups, and then oral histories. So let's understand one by one. What is interview? Suppose you have interview with some celebrities or political leaders, right? So with open-ended questions, generally like say coffee with Karan, those kind of interviews, right? I mean, that may not have some dedicated questions. It is an open discussion, and from the interview, you keep collecting data, right? That is called interview. And what are observations? So observations are basically without interviews. Suppose you want to understand, like in a restaurant, what is the total sale every day? Okay, so what you do, just use, I mean, you just observe, like, okay, for some, in an hour, how many, how many customers are visiting that restaurant, right? So that based on your observation. So it does not have interview. I mean, you are not interviewing any, you are not interviewing any of those customers, but you are observing, being a silent observer, right? So that's called observations. What is questionnaires and surveys? Questionnaires and surveys are also kind of interviews, but this has dedicated set of questions and surveys. Okay. For census, remember, this is a good example of questionnaire and surveys. For census, there is a properly well organized questionnaire before collecting data. Even sometimes in some of the interviews, you may have said like say 10 to 20 questions only, all predefined questions. So those are called questionnaires or surveys. What are documents and records? So documents and records are again like secondary data, like someone collected documents or records long back, and you are collecting for the second time, like say attendance records, meeting minutes, right? Financial records, those things. So say these were collected as primary data in history, but once you are going to use it, that becomes secondary, right? So documents and records are those kind of collected data. And what are focus groups? Focus groups are like a combination of interviews, okay, by surveying or by observing, right? But you have a dedicated focus group, okay, like say some individuals, separate individuals, okay, which I mean, say you want to interview some of the celebrities only, so that becomes your focus group. Suppose you want to interview some of the political leaders only, that becomes your focus group, right? So you have a focus group actually. And what are oral histories? Oral histories like some earlier recorded audio or video, right? Some preservation, okay, some historical information, which becomes secondary, right? When you're going to use it. So that's called oral histories or secondary data. I mean, this is one kind of secondary data. Right? So did you understand all of these different methods of collecting data? Yes, in chat box or no in chat box?
Yes.
Okay, okay, great. So these are different types of collection methods for data. So that's important for you to understand, like how statisticians collect data. Okay. Um, I have some chat. Just sorry. What is your question, Arjun? Can you please unmute and speak about it? Okay. Okay. So now, once we, I mean, there are several types of methods of collecting data, right? Um, so there are some sampling techniques. So what happens? Why sampling is important? Sampling is important because we have a large data, right? Large data or big data, okay, large area, and sometimes it becomes impossible or it becomes very difficult to capture population. Population means whole data. I mean, suppose data for whole country or data for whole world. So data for whole world is kind of impossible to achieve, right? So instead of collecting data for the whole world, we keep some samples and then we collect data from those samples. So what is sampling? Sampling basically is a method by which you can try to reduce the population, but still you draw a representative sample for the population. That's important. So remember the word representative sample. Okay, that is very important. So in representative sample, what we do, though we collect um, though we collect data in subsets or subsamples, but still it represents the overall population. So due to difficulty of not being able to collect data from population, we draw some samples or subsets from the population. And for those subsets, if we collect data, those data should be representing the population. Right? That's the concept of sampling. So now there are two types of sampling. One is probability sampling, one is non-probability sampling. What is non-probability sampling and what is probability sampling? What are the differences? So like non-probability sampling has selection based on some subjective judgment of the researcher. Suppose I have some convenience. I want to collect data from some nearby localities only because I can't go far. That is a non-probability sampling. Okay, and what is the probability sampling? Probability sampling is selected at random. I mean, irrespective of my judgment, irrespective of my convenience, still we draw sample based based on some probability. Okay, and this we draw randomly. Okay, it has no chance. Like in non-probability sampling, we draw samples based on our judgment or based on some subject or based on some preference, etc., convenience, etc. Unlike that, we keep drawing samples randomly. Okay, in non-probability sampling, not everyone has an equal chance to participate, right? Obviously, because I'm going to select uh, through my judgment or my preference, etc. That's why not all are going to get participated in my survey. But in probability sampling, everyone in the population has an equal chance of getting selected. Okay, because of random selection. And what is the third difference? The researcher does not consider sampling bias. So basically, what is sampling bias? Sampling bias is that bias when you draw a unrepresentative sample of the population, that time this sample does not represent the population, and that's a bias, right? So that sampling bias is very high in case of non-probability sampling, and that sampling bias is low in case of probability sampling, because probability sampling is random at random, right? So you're not, there is no bias actually, there is no judgmental bias, there is no observational bias. So the sampling bias is much reduced compared to non-probability sampling. Okay, useful when the population has similar traits. So when do we go for non-probability sampling? Suppose I know that I already know that okay, this population has some similar traits, so I will survey them only. That time non-probability sampling we can use it. But when can we use probability sampling? When we are unsure of the population and when the population is diverse. So when the population is diverse, we should never do non-probability sampling. Instead, we should do probability sampling. Okay, and and I mentioned, as I mentioned, like non-probability sampling, the sample does not accurately represent the population. Okay, and in probability sampling, so basically we create a accurate sample, and accurate sample means representative sample, so which represent the population. Okay, and for non-probability sampling, finding respondent means the people whom you are going to survey, right? That is easy. Why easy? Because this is based on my judgment, my preference, my convenience, right? So always it will be easy to get those kind of responders, I mean respondents who responds to our survey, right? And what is the in case of probability sampling? Finding the right respondent is not so easy. Why? Because suppose I want to cover all the males, all the females, all income groups, right? Sometimes what happens if we pick randomly, uh, sometimes by chance it may not be all. I mean, it may be say all males by default. I mean, I don't have any bias, but by chance it may be possible that okay, it can be more males than females. Sometimes it could be possible that more higher income groups than lower income groups, those things. So finding the proper representative respondent is not so easy in case of probability sampling, but it's easy in non-probability sampling because that is based on my judgment, my preference, my observation, my convenience, right? So did you understand what's the difference? What are the differences between non-probability sampling and probability sampling? Yes or no in chat box? Okay, good. So let me explain you some of the methods for probability sampling as well as non-probability sampling. Okay, so what are the different ways by which we can do probability sampling? There is random sampling, which is also called simple random sampling. There is systematic sampling, there is cluster sampling, and there is stratified sampling. So what is simple random sampling? Simple random sampling, like what we do, we draw some random numbers, and based on those random numbers, suppose I have say total population is say 10,000, you know, so out of 10,000, I mean, what you can do is you can draw say 200 or say 500 random numbers, okay, and you get random numbers like say first random number is 100. That means you will go to that 100th person, okay. Second random number is suppose second two, okay, so you'll go to second person. Third random number is say 10,000, so you will go to the 10,000th uh, person. Suppose fourth random number is 101, so you'll go to 101th person, and so on, right? So this is based on random numbers generated, and then accordingly you keep collecting from the from that respondent or that person or that locality, etc. So that's called simple random sampling. Okay, like say, what is an example? Suppose in a black box I put some red balls or red, I mean I put red balls, blue balls, black balls, and yellow balls. Okay, and I ask any one of you like, okay, can you please draw one ball randomly, and you just insert your hand and you pick up one ball, right, without seeing it, right? That is an example of simple random sampling. Okay, so when you are picking picking a ball from a black box, you have no bias, no judgment, no preference, no convenience. You're just drawing it randomly, and any ball, I mean any of the red ball, yellow ball, blue ball, or some other ball, other colored ball, has equal chance of getting selected. Remember, okay? So that's an example of simple random sampling. So what is systematic sampling? Sorry. So systematic sampling is based on some systematic procedure. What is that? Suppose every fourth every fourth respondent you will be picking up. So that means first observation you are picking up, and then suppose you are picking up the fifth observation. After fifth observation, you are picking the ninth observation. After ninth observation, you are picking the 13th observation, and so on. Or say each 10 gap, right? So first and then 10th and then 20th and then 30th and then 40th, etc. So it has a systematic procedure that's called systematic sampling. Okay. What is cluster sampling? Cluster sampling goes through two stages. One is having single stage cluster sampling or two-stage cluster sampling. Okay. So what is cluster actually? Basically, cluster is a subgroups. Okay, some subgroups of population instead of individuals. So far, I was talking about individual respondents, right? Like in case of simple random sampling, it was individual respondent. In case of systematic sample, also it was individual respondent. But in cluster sampling, like we'll form some clusters, like say clusters of areas or clusters of population and so on. And then from that cluster of area, cluster of population, I'll interview all the respondents. So this is called cluster sampling. Got it? What is stratified sampling? Stratified sampling is basically this is like similar to cluster sampling, but what we do, we form some stratum. Okay, so stratum means like one stratum means population having equal characteristics. Okay, population having equal characteristics. Like say some subgroups we are going to define from the population, and one stratum will have homogeneous group, another stratum 2 will have homogeneous group, stratum 3 will be having homogeneous group, and stratum 4 will be having homogeneous group. And then from stratum 1 I'll do some simple random sampling, okay, subset of that stratum. From stratum 2 I'll take some subset randomly, from stratum 3 I'll take some subset randomly, and so on. That is called stratified sampling. Is it clear to all of you what are the different types of probabilistic sampling methods? Okay, excellent. Now let me define some of the non-probability sampling. So what is non-probability sampling? Non-probability sampling is like convenience sampling, like based on our convenience, right? So it could be like, say we are staying in an area, and I'll survey only those people because I stay in that area, and then getting respondents from that area will be much convenient to me, right? Okay, that's called convenience sampling. What is consecutive sampling? Consecutive sampling is like we keep collecting records over a time period. Okay, suppose I go to the same population. I mean, not population, same sample, same respondents, but I keep collecting data over some periods of time. Like say, first month I collected data, then second month I collected data, okay, third month I collected data. Sometimes this is useful for medical research also. Okay, so this is called consecutive sampling. I mean, we keep collecting data from the same respondents at some consecutive time points. What is quota sampling? Quota sampling, like you know about SCST quota, similar to that. Like um, say I want to have say um, some definition. Suppose I'm going to choose 100 observations. So out of that 100, 25 must be of first year students, 25 must be second year students, 25 must be from third year students, and 25 must be from fourth year students, right? This is kind of quota, right? So like equal quota, like say 25% from uh, class one, or say year one, okay, 25 5% from year two, 25% from third year, and 25% from fourth year. So this is called quota sampling. Based on some quota, we will draw the sample. We'll draw the, I mean, we'll conduct the survey from those respondents only. And what is judgmental or purposive sample? In judgmental or purposive sample, I have some purpose. Okay, I have some judgment based on my experience, based on my domain knowledge, based on some researchers' knowledge. Okay, so the researcher will be knowing better that okay, which respondents he should go to, right? So he has predefined knowledge, and based on that knowledge, based on that judgment, and based on the purpose of the problem, he can collect the data, right? And what is snowball sampling? Snowball sampling, like basically, this kind of sample has a sample size small, and generally this is not easily available. Okay, like it works like some referral program. Okay, so I suppose I explained to one of you that okay, I'm collecting data. Could you please identify this kind of respondent? Again, that guy will refer someone, right? And then third network guy will refer someone, and that's how it will keep going. The sample observations keep going. That's called snowball sampling based on some referral concepts. Okay, got it? Like say LinkedIn referral and those things. So did you understand all the methods of non-probability sampling? Yes and no in chat box. Okay, good. So collection is over. Okay, data collection is over. Remember, I am going phase by phase. So collection, tabulation, okay, visualization, analysis, interpretation, and reporting, right? So collection part is over. After collection, what do we do? Okay, after collecting raw data, we tabulate the data. And why it is important? It is important because I want to represent the raw data in some simplified manner. Okay, suppose the raw data is complex to understand, I want to present in simplified manner. That is one benefit. To bring out essential features of the data, I'll show you one example, that time you will understand. To bring out essential features of the data. So what happens? Raw data is a hugely unstructured. I mean, it could be lying here and there randomly, right? and that may not depict the true features of the sample or population. So what we do, we tabulate it and it helps us bring out essential features from the data. And to facilitate comparison, I'll show you one example again. So to facilitate comparison, suppose I want to tabularly, I want, I present the data tabular format. That time I can compare between different columns or different rows. Okay. And obviously to facilitate statistical analysis, because uh, if we do not form the tabulation, it may be difficult to come up with statistical analysis or data science or data science model or machine learning model and so on. That's why tabulation is important. And what is the last one? Like saving of space, right? Suppose your data is a haphazard, right? So that haphazard data will take lot of space, lot of memory in your computer. Suppose you are going to store in computer. So instead of that, we create some tabular formats, and that those formats take less space. Okay, and it's well structured. So these are several benefits of tabulating some collected data, right? Like let's say some, let's uh, let's show some examples. So this is like qualitative classification. Like I have gender, and for each gender, like urban population, rural population. So urban boys, like males 200, rural 390, urban girls 167, and rural girls 100. So how this is important? Now let's say let's compare the benefits. I said to simplify the complex data. Yes, it is simplifying. I said to bring out essential features. Essential features means quickly you can uh, chalk out some features like, okay, from urban, my male population is 200. Just for example, for rural, my male population is 390. So this is, sorry. So to bring out essential features to facilitate comparison. Comparison, yes, comparison is also possible, right? So what is the comparison like urban and rural? Comparison between boys and girls. So comparison is also happening here. And to facilitate statistical analysis, obviously, if I'm tabulating this, it is going to help me statistically, because this is a statistical tabulation. This is called 2 plus 2 table. Okay, contingency table. This is also called contingency table in statistics. Uh, and to save a lot of space. Suppose I had individual records like say 1, 2, 3, 4, 5 till thousand or 600, etc. Storing that data and storing this data will be taking lot of less space and less time, right? So that's why tabulation is important. One more tabulation, suppose marks is a range like 0 to 50, how many students got between 0 to 50, how many students got from 51 to 100, and so on. Okay, this is again one more data, like say for each year I want to understand the sales, right, of some product. This is the tabulation for that kind of data. And suppose this is some special data, like for each space or country, what is the number of teachers, like say India 1,39,000, Russia 43,000, and so on. Okay, got it. So understood the tabulation, yes or no? Hello, quickly. Okay. Now tabulation is over. So collection is over, tabulation is over. The next section I discussed, visualization. What is visualization? As you obviously know from the definition itself, visualization is how we are going to visualize the data by generating some plots or graphs. Visualization is a technique by which we visualize the data by having some plots and graphs. Okay. So what are the benefits? Answer questions or discover them, make decisions. I'll tell you, see data in context, right? Support graphical calculation, find patterns, present your argument or tell a story, right? Inspire to do more. Okay, now I'll talk one by one. So answer questions like say, if I present graphically, like I can identify like which interval has highest population, whether male population is higher than female population, and so on. Make decisions. Make decision that okay. I mean, if you see that male population is higher than female, obviously your decision will be yes, I decide or I conclude that male population is higher than female population, or say female population is higher than male population. That is at some village or in some city, etc. Right? To see the data in context, right? What is the context? Like say I'm generating say sales data, whether I'm going to visualize sales data, whether I'm going to visualize population data, that is also clear from visualization. That's why see the context on the data. Support graphical calculation, obviously it will help you to graphically calculate like, so what happens is in y-axis there is some range and x-axis there is some range. So from y-axis range you can identify like which particular value it has. I'll show you an example. Like for male whether it is 500 or say 5,000 etc. For female whether it is 100 or 200 or say 10 lakh etc. Right. So that graphical calculation is pretty easier from the visualization. Directly you can visualize and find patterns. Obviously like you can generate some patterns for male and female, generate some patterns for some ethnicities, generate some patterns for some locations etc. And fourth, fifth thing is present your argument or tell a story. So through visualization, it is pretty easier to explain to your managers or explain to your stakeholders, explain to your client, right? Instead of having too many jargons, through visualization, it's pretty easier to make them understand like what you have generated or what you are going to present to them, right? And once you present graphically, right? So and graphically, everybody will be attracted, right? And once you can attract your manager, once you can attract your clients, obviously they will be investing more in your project or in you or in your team, right? So that's how visualization are having numerous benefits. Okay, now let me show you some of the plots and graphs by which we can visualize data. So initially said, suppose we want to have number of births in hospital for different hospitals like hospital A, hospital B, hospital C. So this is also known as column diagram or bar diagram. Okay. Okay. So and suppose we are going to compare temperature in cities like minimum temperature, average temperature, and maximum temperature in a day for say London, Madrid, Paris, and Lisbon, or say some country, city 1, city 2, city 3, city 4. So for city 1, what was the minimum temperature, average temperature, maximum temperature? For city 2, what is the minimum temperature, average temperature, maximum temperature? Same for city 3, same for city 4. So this is if you compare, it's comparable, right? It's comparable. It can numerically present your data. Suppose for Madrid, the maximum temperature is 25. For Paris, the maximum temperature is 30, etc. Right? So you can calculate also. You can compare also. You can tell your story also, right? So this is called histogram. So in histogram, what we do is we in the x-axis we keep some intervals like 0 to 5, 5 to 10, 10 to 15, and in the y-axis this is frequency. Frequency means number of happenings. Okay, so 0 to 5 happened. I mean there are observations. I mean there are 30 observations or 32 observations. Sorry, this is 10, 0, 10, 20. Okay, so 12 observations in the group of 0 to 5. There are say 14 observations in the group 5 to 10 and so on. This is called histogram. This is called pie diagram. Okay, so pie diagram generally captures the percentage of different subgroups. Okay, suppose you want to draw the pie chart for transportation to school. Some students come by walking, by foot. I mean, some students come by bus, some students come by train. Okay, so coming by train, so 17% comes by train, 33% comes by walking, and say 50% comes by bus, right? So it is clear. You can compare, you can calculate, and so on. You can tell a story also. And this is called pictograph. Pictograph is important. Like say complete figure of male, that means 4 boys, and complete figure of female, that means 4 girls, and half half of the pictogram means 2 girls or 2 boys. Okay. Suppose age 14. Age 14 means 10, 4, 4. So there are 8 males and 4 plus 2, 6 females for age 14. Age 15, I have 1, 2, 3, 4, 5. So 20 males and 16 girls. For age 16, I have 12 males and 8 girls. For age 17, I have 6 males and 4 girls. Right? This is called pictograph. And this is called stem leaf plot. What is stem leaf plot? Stem leaf plot, suppose you have values like 41, 43, 49, 52, 57, 67, 68, 69 originally. And how can we represent that? So first take the first digit on the left hand side. So this column 4, 5, 6, 7, 8, 9, and then put the values, second digit here. So 1, 3, 9. So this means I had originally 41, 43, and 49. Put 2 and 7 if you had 52 and 57. put 7, 8, 9 if you had 67, 68, 69, and so on. 70, 72, 73, 73, 73. I have some observations. 81, 82, 82, 92, 96, 100, 108, 112, 114, 123. This is called stem and leaf plot. Okay. This is called box plot. In box plot, like this is minimum observation, the minimum value. This is the maximum value. This is quartile one value. This is median value. This is quartile three value. I'll explain you what is Q1, Q2, Q3. This is Q1 value. This is Q2 value. This is Q3 value. That's how we generate box plots. This is called box plot. This is called line graph. Suppose I want to, or time series graph. Okay. Suppose I want to view weekly channel audience. Okay. So this is like for each week, like Monday, I mean, for each day, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Mondays, I had suppose 220 or 230 audience and so on. And by these lines, you can quickly understand like how your channel audience is performing over different days. Okay. This is called frequency polygons. Frequency polygons is same like histogram, but if you join the midpoints, that becomes frequency polygons. This is called scatter plot. Okay. So scatter plot is a bivariate plot which plots between y and x. Suppose this is my dependent variable y and this is my independent variable, and you plot all the points. This, if you plot like this is called scatter plot. This is density plot. Density plot is like statistical distribution. Okay. So this is for 3-dimensional density plot, and this is 2-dimensional density plot. This is a normal distribution. Okay, normal distribution is like a bell curve. I'll explain you what is normal curve when I'm covering say probability distributions. But for now, these are different types of graphs and plots. Is it clear to all of you? I just thought to give you a glimpse of different plots and graphs so that you understand. Excellent. Thanks. Now let's move forward. So once collection is over, tabulation is over, done, visualization is also done. The next fourth part is analysis, right? How do we analysis? So to analyze data, we do something before the analysis. I mean, how do we prepare that? And at the time of data analysis, what do we do? So basically steps in data analysis, what do we do? Understand the baseline or the as-is scenario. Okay. What is the current stage? Okay. I mean, what stage are we currently? And we understand like sources of data, like different sources of data. Okay. I may have suppose different tables. I may have different databases like SQL, Teradata, PostgreSQL, etc. Those are different sources. I may have different Hadoop lakes, right? Data lakes. So I can identify the data sources which can be representative of the population, right? And then I create a problem statement, like which problem statement I'm going to solve it, right? Define the target. Target means dependent variable, like what is your problem statement? Is it churn prediction? Is it loan defaulters prediction? Is it some sales prediction, and so on? Then based on the problem statement, you do sampling, and based on sample, you collect data, subset of the data, and then you chalk out the analysis plan. Okay. Chalk out the analysis plan means like what will you do, what results you want to achieve, and so on. And after this data processing or sampling or those things, man, initial plan, what do you do? Like you process the data, you prepare the analysis data set, you generate tables and graphs, you do analysis and model building, you interpret the results, and then finally you present and report to the stakeholder or management, right? So this is the different aspects of data analysis. And what is the purpose? Purpose is to answer research questions and to help you to determine the trends, patterns, relationship among variables. Okay, so what do we do data analysis? So this data analysis is the next phase after collection, tabulation, and visualization. Okay. So now statistics has two perspectives. One is descriptive statistics, one is inferential statistics. So let's understand the differences. What is descriptive statistics? When we have some data after say sampling or after collection through different methods, right? We have some data, suppose. Now, if we have some data and we just want to summarize, get some summary of the data or say plot some of the variables, right? Okay, so basic thing is we do some simple things. Okay, that's called descriptive statistics. Why descriptive statistics? Because through some statistical measurements, or some counts or frequencies, etc. We just describe the data. Okay, and this description of data works for sample data. Okay, so this description of data works for sample data. Generally, um, generally we cannot infer something. Suppose we are collecting sample data, right, and you are describing the sample data only, so it has no relation. It may not have it may not have relation to the original population. Okay, so that's the difference for descriptive statistics. And what is inferential statistics? In inferential statistics, basically what we do is, okay, suppose for some sample, okay, we do all the calculations, right? We generate some of the trends, some of the patterns, etc., and we test some hypothesis. Okay, like say from sample data, suppose my sample mean is say 50. Okay, so can I infer that this sample mean 50 is also the population mean? That means sample I got sample mean as 50, but is 50 the mean for a population also? That kind of inference we can do using inferential statistics. Okay, descriptive statistics we can only do some summarization, and inferential statistics we can infer about the population. So these are the two different differences, right? So what is descriptive statistics and what is inferential statistics? So from inferential statistics, we draw conclusions based on sample data. We draw conclusion for population based on sample statistics. Okay, got it clear? Is it clear? Yes, no? Okay. Okay, so we have descriptive statistics, we have inferential statistics. Now let's move forward. So what are descriptive statistics? How can we do descriptive statistics? There are several ways again. Like we can check frequency distribution. There are measures of central tendency, measures of variability or dispersion, skewness, kurtosis, correlation, and regression. Now one by one, I'll cover these topics. Okay. So what is frequency distribution? Frequency distribution is basically a systematic arrangement of numeric values from the lowest to highest. Okay, and it has some frequencies, like as many times the observations or groups happened, we just need to properly represent that frequency for each individual value or each individual group. I'll show you one example, you'll understand. And there are three types of frequency distribution: simple frequency distribution, group frequency distribution, and cumulative frequency distribution. So what are these actually? Suppose I have raw data like this. Suppose marks of 100 students in a class, in economics. Okay, like 72, 61, 63, or go by this one, 72, 69, 64, 64, this one. 100 scores, I mean scores for 100 students, economics class students. Okay, these are the different scores, individual scores. Now suppose I want to get a frequency distribution of this data, raw data. So this is called tally marks. Okay, I'll explain you. So marks, like I'm putting the individual marks like 56, 57, 58, 59, 60 till 673, because 56 is the minimum. If you check from here, 56 is the minimum. Where is 56? Okay, anyway, I mean 56 is, see, this is the 58. Okay. Anyway, so 56 is the lowest
It's in
observation.
second column, second row.
Oh, sorry, this one is 56, right? This one is 56, and 73 is this one. Okay, this is the maximum value, 73. Okay, I have already put bracket actually. I forgot. So 73 is the maximum number, right? So 56, 57, 58, 59, until 73. Now what we need to do, we need to count the observations, the marks. 56 is only one, so this is one. This is called telemark. Okay, 57 is two, so this is 157 and another 57 and this one. So one telemark and then two telemark. So quickly you can count the telemarks and you get the frequencies. So for 56 it is 1, 57 it is 2. Similarly for 58 it is 2, 2. Okay, now let's say 61. 61, how do we represent the telemarks is, initially we draw 4 telemarks and the fifth one we cross it. Okay, we draw like this. That means this is 5. If you look at it instantly, you know that this is 5. Okay, so 61, this is 61, this is 1, then 1, 61, 2, 61, 3, 61, 4, and 61. Okay, anyway, so 61 is 6 times. Okay, so for so initially we draw 4 telemarks, and the fifth one we cross it, and then again we start from new block. So 1. So this quickly you can see that this is 5 plus 1, 6, and this is 5 plus 5 plus 5, 15. This is 5 plus 5 plus 1, 11. This is 5 plus 5, 10. This is 5 plus 5 plus 4. This is 14, and so on. That's how you represent the frequencies. This is called simple frequency table or simple frequency distribution, because in simple frequency distribution I have frequency for each individual data points. Okay, that's called simple frequency distribution. What is grouped frequency distribution? So grouped frequency distribution is this one. Like I have some groups, like say 41 to 49, 50 to 58, 59 to 67, and then accordingly we have telemarks like 3, 6, 5, 6, 2. So these are frequencies for individual groups. Okay, not individuals but groups. This is called grouped frequency distribution. And what is cumulative grouped frequency distribution? So add these. Okay, so 3, and then 3 plus 6 equal to 9, 6 plus 5 equal to 14, 14 plus 6 equal to 20, 20 plus 2 equal to 22. What does it mean? That 77 to 85 and less than this, I have 22 total observations. So till 76, I have observation 20. Till 67, I have observation 40. Like this, it represents, right? So this is called group frequency distribution, and this is called cumulative group frequency distribution. Is it clear to all of you? Yes and no? Yes or no in chat box? Clear?
Yes.
See, I'm trying to explain in very lucid way, so that all of you understand, right? Even if you do not have knowledge, but still you will understand. Okay, so good. So we have understood now. Now I'll talk about measures of central tendency. Remember, I prefer um, to go from right to left. Okay, and you will never forget this. So what is the definition? Tendency to tendency to move to central value. That's how I define tendency to move to central value. What is central value? Central value of a data is that value which is the middlemost, or say it represents the all it represents the all observations, like say average, mean. Okay, one central value is mean, another central value is median, another central value is mode. I mean, there are different central values like mean, median, or mode. Okay, even in case of mean, I have arithmetic mean, I have geometric mean, I have harmonic mean. So what is arithmetic mean? Arithmetic mean all of us know, like from the class 4 or class 5, depending on your board. Like say x bar equal to, I mean, sum of all the values by number of observations. That's called mean, simple mean or arithmetic mean or the average. Sum of all the values by total number of observations is called x bar, mean. Okay, what is geometric mean? Geometric mean is like nth root of product of xi, and then nth root is called geometric mean. What is harmonic mean? Harmonic mean is like average, the reciprocal of the average of the reciprocals. This is reciprocal. Average of the reciprocals is average of the reciprocals, and then reciprocal. So this is like this n came from 1 by n. Okay, so this is average of the reciprocals, and reciprocals of the average of the reciprocals is harmonic mean. Okay, so when can we use harmonic arithmetic mean? When can we use geometric mean? When can we use harmonic mean? Arithmetic mean we use when the values have same units. When the values have same units, that time we can use the arithmetic mean. When I may have some observations in different units, okay, that time I will use geometric mean. And when there are some rates, like say rate of growth and those things, we will use harmonic mean. Okay, but most preferably we use always, I mean, mostly we use arithmetic mean, which is 1 by n summation of xi. Right? Got it? Now, similar to arithmetic mean or geometric mean or harmonic mean, we have median also. So what is median? Median is nothing but the middlemost value. Suppose you have 10 observations. If you ascend, I mean, uh, if you order the data from increasing order, like say from smallest to largest, The middlemost value will be the median. I'll explain you. I'll show you some examples for all this. You'll understand. And what is mode? Mode is that value which happens with highest frequency. Remember, mode is that value or that that value which is having highest frequency. Now let's see one by one what are these. What is mean and average? Mean equal to, as I mentioned, like summation of xi by n. If I want to calculate the mean using Python, okay. So what is the script? Okay, import numpy as np, sample data. Suppose my data equal to 4, 7, 12. We are defining in a list. Okay, arithmetic mean formula is mean equals. This mean is our variable name. You can put any name equal to np dot mean. Okay, this is the formula to calculate arithmetic mean. So np dot mean of my data. So this my data, remember, I have only one variable, right? One set. So my data, this will give arithmetic mean, comma mean. Arithmetic mean is 7.6. That means 4 plus 7 plus 12 by 3. If you calculate, it will get 7.67. This is arithmetic mean for this data. Got it? How to calculate using Python? So you understood the average? All of you? Did you understand how to calculate? And what is this about? Yes or no? Okay, so good. Now what is median? Median is, as I mentioned, like it is middlemost value. Okay. Suppose I have odd number of observations. So if I have 5 observations, if I arrange in ascending order those 5 observations, so my third value will be median value. My third value will be median value. Okay. And if I suppose have even number of observations, even number of observations, suppose I have 6 observations. So 6 observations is, if you arrange in ascending order, my third value and fourth value, average of this third value and fourth value will be median. Let's understand that. So some script. So what is median for 4, 7, 12, 17, 22, 1, 2, 3, 4, 5? This is 5 observations, right? Okay. Suppose I have, so this is already in ascending order, but suppose you had 17, 12, 7, 4, etc. Initially, you needed to increase order. Okay, I mean arrange in ascending order. Like ascending order will be 4, 7, 12, 17, 20, 22. So this is 1, 2, 3, 4, 5. So 5 observations. So remember, for odd number of observations, middlemost value is third value, right? This side 2, this side 2. So 12 is the median. Okay. So let's calculate the median. Median equal to np dot median. Like np dot mean was for arithmetic mean, so np dot median is for median value of my var. This is my var. So median will be 12, right? Suppose I have 4 observations. 4 observations, that means second and third value, average of the second and third value will be my median. So what is the median? Median equal to np dot median, my var, print median, which is 9.5. 9.5 is nothing but second observation plus third observation, second value plus third value by 2. So 7 plus 12 by 2 is 9.5. Did you get it? What is median? All of you?
Yes.
Okay, good. Now finally, let's say mode. Okay. So mode, I mentioned that the value which is having highest frequency. Suppose I have the data set like this: 4, 7, 12, 12, 17, 17, 17. Can any one of you tell me what will be the mode for this data set? Mode is that value which occurs with highest frequency.
12.
Which is, yes, 17. Apurva, Sai, yes, you are right. Okay, so what is the formula? So that mode formula will come from stats package. So from SciPy, this is one of more popular package, NumPy, Pandas, and SciPy. SciPy is for scientific Python. From SciPy, import stats, mode equal to stats.mode of my var, and print mode, comma this mode. So result will be 17. So the result will be coming like this, and it will show the respective frequency also. So 17 value, value 17 has the highest frequency, which is 3. 12 has 2 frequency, right? 4 has 1 frequency, 7 has 1 frequency, 12 has 2 frequency, and 17 has 3 frequencies. So 17 will be my mode. So that's how you can calculate mean, median, and mode. So let's end the session for today. Let's end the session here, and we'll continue from measures of dispersion